in Central
I
Hyderabad.
finished PhD in 2006 from University of Hyderabad.
Okay.
Yeah. Then I'm here from 2008 in Kolkata.
Oh.
At ISA Kolkata.
Sometimes you keep coming to Hyderabad?
Right.
Okay. We'll meet
Right.
sometime.
Last month I was
come.
there for a couple of days. I gave a talk in chemistry department there. Yeah, I keep visiting University of Kolkata.
So we'll start with the session now.
Yeah, sure.
Good afternoon, everyone. Welcome to the second session of Interaction with India Science Geniuses series. And I'm Sonal Shubham from American India Foundation. In the last session, we had Dr. Archana Sharma, Principal Staff Scientist, CERN, with us, who talked about her academic journey, various discoveries like Higgs boson, and the challenges that they have faced during their research. She also spoke about her vision for the girl students in India towards STEM career. Before we start today, we would like to show you a video to give you an idea of the book, India's Science Geniuses, on which this entire series has been planned. Mandeep, can you play the video? Thank you, Mandeep. Now I would like to invite Gopal Krishna sir to share a few words on this series. Welcome, sir.
Thank you. Thank you very much. A very good afternoon to all of you. It's my pleasure and privilege to wish you all a very happy 74th Republic Day, which we are going to celebrate in Pomp Show tomorrow. On this happy occasion, I welcome you all to this lecture series based on the book India's Science Geniuses by Dr. Archana Sharma, CERN scientist. The lecture series was initiated in December 22 under this Vigyan Jyoti program to provide an exposure of science and research to the girl students through interactive lectures every month with eminent scientists of India who are featured in the book. Through this lecture series, it is our desire and aim and our intent to connect our children with the eminent scientists of India. And the first lecture by Dr. Archana Sharma was enjoyed by all Vigyan Jyoti girl students as their aspirations were elevated by listening to her inspiring life as a woman scientist. For the second session in the lecture series, we are extremely fortunate to have Professor Chilla Malla Reddy from the Department of Chemical Sciences, Indian Institute of Science Education and Research, Kolkata. Dr. Sharma's book features Dr. Reddy and illuminates his accomplishment of pioneering research on molecular crystals and molecular materials. Dear Dr. Reddy, I'm sure you would be happy to know that the Vigyan Jyoti program is a flagship initiative of the Department of Science and Technology, which is running successfully in collaboration with Navodaya Vidyalaya Samiti in 200 JNVs all over the country. The program is a huge step in the direction of empowering the girls in STEM field. This program aims at promoting meritorious girl students in their 9th to 12th standards towards underrepresented areas of STEM. Under Vigyan Jyoti, a diverse array of activities caters to all the dimensions of learning. This lecture series will be an immensely valuable addition to the array, as apart from being aligned with the vision of Vigyan Jyoti program. And I'm sure it will serve to generate cognizance about the multitude of STEM pathways. Dear Dr. Reddy, the Vigyan Jyoti scholars are eagerly waiting to hear from you about your life and the wonderful work that you are doing in the field of chemical sciences. We are fortunate to have you among us. To formally introduce our speaker, I request Dr. B.K. Modi, the retired Assistant Commissioner, and now who is an active partner with Vigyan Jyoti program, and he had a lot of experience in the field of school education, and he had been a mentor for generations of teachers and principals when he was the principal and assistant commissioner of the Vidyalaya Samiti. And very recently, he had joined this Vigyan Jyoti team to take this forward for more number of JNVs and for more number of girl students. Now, I take this opportunity to welcome all of you for this program, and now over to Dr. Modi to take it forward. Thank you for giving me this opportunity on this pleasant afternoon. Thank you.
Good afternoon, everyone. Am I audible?
Yes, Modi, you are audible.
Good afternoon, everybody. First of all, I would like to express my deep sense of gratitude to our Honorable Deputy Commissioner, NVS RO Hyderabad, and coordinator of this Vigyan Jyoti program at NVS level. Representatives of American India Foundations, Vigyan Jyoti scholars, principals, teachers. First of all, I would like to express my heartiest thanks to Gopal Krishna sir for giving me the opportunity to introduce today's guest speaker and eminent scientist, Dr. Reddy. Let me tell you, Dr. C. Malla Reddy is currently a professor and head at the Department of Chemical Sciences, Indian Institute of Science, Education and Research, Kolkata. Dr. Reddy has graduated in Crystal Engineering from University of Hyderabad. He has been awarded with prestigious Swarna Jayanti Fellowship in Chemical Science in 2015 by the Department of Science and Technology, Government of India. He also a member of the local organizing committee of the 24th Congress and General Assembly of the International Union of Crystallography 2017, which was held in 2017 in Hyderabad. He is an elected fellow of the National Academy of Science, India. He received Distinguished Lectureship Award from the Chemical Society of Japan. He has published more than 100 research articles in almost international journals. His research group at IISER Kolkata focuses on establishing a structure, mechanical property, correlations for distinguishing various functional solids using crystal engineering principles. Sir, on behalf of the Navodaya Vidyalaya Samiti, on behalf of VJ scholars, I extend my warm welcome to Dr. Reddy. Please give a big hand for him. Sir, we would like to apprise you that Vigyan Jyoti program is a flagship initiative by the Government of India Department of Science and Technology. This initiative is taken for the enhancement of the participation of the female participants in the field of science and technology, engineering, and mathematics. At present, the project is being implemented in 200 JNVs located all over the country. BJ scholars are highly talented, predominantly from rural areas. They have tremendous potentiality and ability to change the world. And we think that today's talk will be very much fruitful for them and they will make the most of it. Sir, when we talk about the interaction with the eminent scientist, when we talk about the motivational speech, when I talk about the chemical science, we do not find any person better than Dr. Reddy. Once again, I extend my warm welcome to Dr. Reddy. Thank you very much.
Thank you so much, sir. I would now like to invite Dr. C. Malla Reddy, the speaker of the day. Sir, over to you. And we have heard about you from Modi sir and Gopal Krishna sir, but we would like to know about your educational journey, your journey to IISER, and about your work from you now. Welcome, sir.
Yeah. Yes, yeah. Thank you very much, all of you, for inviting me, and this is a great opportunity. So how do we start? So first we will take some questions, and then after that I think I can present what we do. I think maybe we'll come back to that a bit later. Is that fine?
Sir, you can start with telling us about your journey, about your academic
Yes.
journey and your journey to IISER, and then we can you can let us know about your work. Yeah.
Sure. See, I come from a small village in Mahbubnagar district, which is around 15 kilometers from Mahbubnagar, which is, again, around 100 kilometers from Hyderabad. So I studied in the primary school in our village, which was up to 5th standard. And so there I have a lot of memories from that school. We had a very strict teacher, headmaster, So headmaster used to send teachers to go around and then see if there is any kid who is playing in the village who is above around 5 years and above and not going to the school. So he used to go and then basically get the kids in those days. Those days, parents were also not so much aware of education, and many people were very casual. Many could not afford, and they used to send the kids to the field even. So then one day, teachers, I was just less than 5. So my father was not yet thinking of putting me in the school, but they caught me and then talked to my father, and then they brought me to the school. That day I still remember that day. And then, principals are just made a loud noise and then said that you just sit and then just sit here. So then I sat, and from that day, then I was very regular to the school. And then I remember that, so it was then I was very regular, and I liked it actually in the end. And then I studied there. That was my start from a very small school. I think it's about, now the population is around 500 to, or maybe 1,000 people there. So then I had to, after I passed 5th, then I had to go to the next school, which was around 2 kilometers away. And then I had to walk every day 2 kilometers to go to that school. We used to get up very early in the morning, pack your bag and food, everything, and then we used to walk. But it used to be fun with friends. When you walk, you don't really realize that you are doing some extraordinary thing. It was fun. Then I graduated 7th class from a nearby school, which is called Kottamolgara. Then after that, I had to, that was only from 5th, 6th to 7th. Then we had to go to another school, which is in a nearby town. Then we had to go on a bus. So we used to go on a bus. And then after that, then I moved. So I changed many schools actually, because in villages in those days, you did not had high schools in nearby places. So you had to go to bigger and bigger towns. Then I studied in Mahabubnagar. And again, in Mahabubnagar, the college was government college. Obviously, it was, teachers were extremely good, but students were not really punctual. There was no punctuality in the college. There's a boys junior college in those days. So there were 2-3 sections. In each section, there were around 60 students. In my +2, around 60 students in each class. And after second year, you would see that from each class, only 1 or 2 students would pass all the classes, all the subjects, and in one go. So I was one of them from my batch, my section. So teachers were extremely good, but students were not serious, and somehow the discipline and all many things were not in place. So it was a kind of extraordinary thing. And although I passed in second class, it was kind of a big celebration in my village and all. Then I went to a degree. Basically, after that, so here after my +2, I was so in my studies also, I always try to take a book and then read the whole chapter rather than just preparing only for the exam and questions. So I never really topped in the exams, but I was also never really bad in any exam. So since I was not really focused on particular questions or important ones, so I used to read entire book. So amount of time was not enough to cover everything and perfect everything, but I was more interested in learning as much as possible in all the chapters rather than focusing on important things. So then, although I passed in with a lot of difficulty in the +2, then there was an entrance exam for Silver Jubilee College. There were 2 colleges. These are government boarding schools. So there was an entrance exam. So I went to Hyderabad. I think, if I'm not wrong, that was my first time or second time anywhere outside this, district headquarters. I never really traveled anywhere other than just, 15-20 kilometers. So for that exam, I went to Hyderabad for probably first time or second time. Then I wrote the entrance, and I was not really hopeful because I was not from a very good college. So luckily, I got the seat there in Silver Jubilee College. And it was one of the best colleges, actually, government colleges, where it is a fully residential and you don't have to pay anything there. So then I went there. Then I saw a lot of bright students there. It was really a great experience. A lot of competition. Suddenly, I realized that it is a very competitive and, very competitive, and then with a lot of opportunities. And kids were also very smart, and all the people knew what they would like to do after they finish the BSc. So I was fortunate, and then I realized that there is something called research, and then I also knew how actually you can become a scientist. What is the path? So that is where I learned. Then I decided to prepare for chemistry entrance, and I like both biology and chemistry, but I was more inclined to chemistry because I had a very good teacher in +2 who taught me chemistry. I was really fond of chemistry. Then since then, chemistry became my love. So then after that, I again MSc, to get an MSc seat in Osmania University or Central University Hyderabad. It was like a kind of a dream. It was not an easy job. So I attempted for the MSc entrance, and then, but I failed. I did not get the seat there in no government college, and my father did not have enough money to support me in any private college. In those days, there were hardly any private colleges. So then I also wrote entrance for the B.Ed exam. Okay, Bachelor of Education. So in that I scored very high because there, you have to be very good in at least 2 subjects. I wrote that in biological sciences, actually. So biology, although I was preparing for chemistry, and my biology test for the B.Ed went very well, and I got 44th rank in the state. That time it was a combined state. So 44th rank, and then I could get the seat in the Usmania campus. And then I got the hostel facility, and it was like, just suddenly I landed in the big university, Usmania University campus. So then I decided to prepare, I attended the classes for B.Ed. Then I decided to prepare very seriously for the MSc. Then I also took coaching. And then that was a very good learning, actually. So teachers were really good. They were also from well-known colleges. So they were very good teachers. They really taught me the deep chemistry there. So then I wrote the entrance, and then I got the seat. After that, then we had a teacher from Central University. She did PhD there, and she just joined in Nizam College. Nizam College is one of the colleges under the Usmania University. So I basically was doing MSc there, and then we had this teacher. So she told me that if you want to do research after your MSc, you have to prepare for an entrance, national level test. If you qualify in that, this is called CSIR or JRFNet or UGC. So if you qualify that, then you can get your own fellowship, and then you can go and join any good lab. Then I didn't know where are the good labs. So she told that you go to University of Hyderabad. There is a very famous scientist there, and you can go and join if you get CSIR. Then I was fully focused on preparing for the CSIR exam. So then I cleared it, because from the beginning I was very keen to, from my BSc days, I was keen to become a scientist. I was very keen in discovering things, and I was just curious about many things. So then I went and joined Professor Gautam Deshiraju. He also happens to be the grandson of Sarvepalli Radhakrishna, our former president. So it was, but he was known for his scientific discoveries. And in those days, almost no one knew that actually he was a grandson of Sarvepalli Radhakrishna, because he never wanted that to, be his identity. So then I did PhD there, and then I was also into a lot of student issues, and in the hostel there is no good food, and these that only get diversions and all. But I knew that my main goal is science, so I was mostly focused on the science, a little bit sometimes getting distracted and all. But I was mostly, I could manage to clear off all the distractions. And then I did very well in PhD, and my work also was very much appreciated. Then after that, I went to Germany for postdoc, and spent there for 1.5 years in Karlsruhe, in a good research institute in the Institute of Nanotechnology. Then after that, I joined in IISER Kolkata as a faculty assistant professor. Then I became associate, and now I am a professor and also head of the department here in the at the IISER Kolkata. I'm going to talk about it for the students if they want to join this institute after +2. This is the right place if you are interested in doing research in basic sciences, maths, physics, chemistry, earth sciences, and biology. If you are interested in this area, and these are the best right now. These are the most happening places in terms of research. So I'm going to show some slide on that and tell you how you can actually enter to IISER system. Yeah, so I'm done with my briefing, and so I think if
sir, you can start us showing the presentation, and students will ask questions at the end once this is over. Yeah.
Yes, sure, wonderful. So I will show you. See, I work on crystals. Okay, so I will share the slides. So. Okay, can you see?
Yes, sir, it is visible.
Okay. Yeah. First of all, I'll just tell you about IISER Kolkata. So I hope all of you know IISER means it is called IISER. The full name is Indian Institute of Science, Education and Research. There is also Indian Institute of Science in Bangalore. So it is a very well-known institute. So it is a similar kind of a model. So we have now several institutes in India. And here you have IISER Kolkata, which is just north of Kolkata city. So Kolkata city is somewhere here. So then these are our hostels. Our students stay here. And then this is our research complex. I hope you can see my, yeah. So this is the research complex. I am sitting somewhere here right now. And this is our teaching complex. So all the students, BSMS students and all basically sit here and take the classes. And then you have several IISERs. Okay, one is IISER Kolkata and IISER Pune started in the beginning, and then after that Mohali, Bhopal, and Trivandrum and Tirupati, Berhampur, all these have come up. So these are IISERs. So basically here we have BSMS program. It is a 5 years integrated program. So students can join here just after their +2. And this has to be, you can come through the basically kind of an entrance exam. I will show you where you can find the details of the entrance exam. And we also have integrated masters. Suppose if somebody finished BSc, then they can also come after the BSc, they can join the integrated masters and PhD program. Or if somebody has already done the master's program, they can directly come for the PhD as well. So then PhD means basically they work in the research labs, state-of-the-art research labs, and then they can basically discover things on their own. So, our group actually works on the solids. Okay, solids. There are several types of solids, and there are some materials which are called crystalline materials. Okay, what are these crystalline materials? So first of all, I think all of you have studied the different forms of matter, right? So what are the different forms of matter? Gaseous state, right? You have gas, particles, and then which basically move around and collide, and then basically they are very dynamic, right? So this is a gaseous state. If you take any material, so these materials can exist in, most materials can exist in 3 different forms. So we have 3 different forms in general. So this is a gaseous state. Then you have liquid state. In liquid state, the particles or molecules or ions are basically much closer, and then they occupy the space that you put them in a container, right? So they are very dynamic. Again, they have a lot of degrees of motions, and then they can move around much, but they have less amount of degrees of freedom as compared to the gases, right? Then what are solids? So solids are basically not having long-range translational movement, right? So these can move in their own position a little bit. These are like thermal vibrations, but they cannot go away from their position. So they are in fixed position. So these are called solids. In solid state, the matter has its own shape. The matter does not flow, right? This is the difference. So in gases, they have all degrees of freedom. In liquids, they have less degrees of freedom. They can flow, but in solids, they are confined and they cannot flow. They cannot flow. They are rigid, right? So these are different states of the matter. So now I say that our lab works with crystals. Okay, what are crystals? I hope all of you have seen crystals. Have you eaten crystals? Have you played with the crystals? I'm sure all of you did. Okay, I'm going to show what are crystals. Okay, there are many crystals around. You might have seen something looking like this, or something like this, or something like this, or something like this. Have you seen this here in your kitchen? Okay, this is a salt crystal. Okay, table salt. If you look at very closely, they look like this. If you put them under a microscope and then look at them, they look like this, and then they have very nice sharp face edges, and then very clean surfaces, and they are very shiny. Okay, so what is the difference between these crystals and any solid? What is the uniqueness about the crystals, right? So I will explain what are crystals and what is the speciality of the crystals, right? Okay, what is a crystal? Do you know what is a crystal? So this is a structure of a crystal, right? So if you look at the diamond, and if you have a technique to see the atoms, so they will look at like this. You will see something like this. Okay, Is it clear? If you see, they are very much ordered. They are very much ordered and they are in the fixed position. Still confusing, right? It's not very clear. Okay, I'll make it even more easier for you. Can you see this? What do you see here? You have people, obviously soldiers, but this is not a crystal, I am sure. But you see something here, right? So if you see, they are in rows, right? They are very much ordered. You see a clear order here, right? They are in, the arrangement is very systematic. So in the crystals also, you have molecules or atoms or whatever you have in the crystals. So they are also very much ordered. They are in a very systematic fashion, okay, arranged in a very systematic fashion. So in crystals, you have repeated, the units repeat themselves. So you have a systematic arrangement. So those are actually crystals. Whenever you have systematic arrangement like this in a solid, okay, then you call them as crystals. Is it clear? Then what are the other possibilities, right? If it is not a crystal, for example, but it is still a solid. So as you can understand from this image, if it is a crystal, the molecules or atoms are arranged in a very regular fashion. As you can see here, they all are arranged in a very regular fashion, right? So these are all atoms arranged in a regular fashion, the way you see here. If it is not a crystal, what do you see then? So it should be like this, right? If it is not a crystal, so then people are here randomly arranged, right? You don't have order. So if you don't have order, solids can have random arrangement of constituents, or they can have a very systematic arrangement. If they are having systematic arrangement, then you call them as crystals, right? You must have studied in solid state, right? BCC, FCC, and many things, right? So those all are the classifications of the crystals, right? So where are the crystals? So these are everywhere. Okay, in our body we have, for example, if you look at bone, okay, calcium phosphate, it exists in crystalline form, but we can't see, like, salt or sugar, if you take in front of your eyes, you see that they are crystals, right? Even ice cube is a crystal. You see them very clearly, but here you would say that, so this is not a crystal, this is a bone. But if you look at it under microscope, or if you have a microscope, okay, which can show you micrometer scale particles or a nanometer scale particles, you will see that they are crystals actually. So many of these are formed by crystals. Even in our eye, okay, we have crystalline materials. So these are everywhere. Even these shells are also formed by the crystalline materials. And even on the leaf, you will see that, some leaves have basically crystalline materials on the surface. So crystals are basically everywhere. If you take the rock or sand, if you take any metal piece, a steel or something, so all these are actually crystalline materials, and crystalline materials are everywhere almost. Okay, but simply we don't know that these are all in crystalline form. Okay, glass is an amorphous material. In the amorphous materials, what is the arrangement? So basically the arrangement would be like this. So their particles are arranged in a random fashion. So if it is crystalline material, so you have regular arrangement. So in our group, we work with the crystals. Okay, so why we need to study about the crystals? So as you can see, these are all very nice crystals. So they have nice shape. All of them look very similar, right? So they have nice faces, sharp faces, and they all look same. Why do they look same actually? Is there a reason? So if you see here, this is basically ice. If you look at the ice, it has hexagonal shape. Why it has hexagonal shape? What could be the reason? The other ones are not hexagonal. So for example, if you look at here, they don't have hexagonal shape, right? They look like rods. But if you take this compound, anytime you crystallize from same conditions, always you get exactly the same type of crystals. But if you take ice and then you crystallize, you will, in the same conditions, you will get exactly like that. So each material forms their own crystals. For example, if you take sodium salt, it will grow like a cube, because their internal arrangement basically determines the shape of the external crystal, right? So all of you know, you have a pencil with you, right? So in pencil, you have this nib, right? This black gray color one. And then, so if you look at in that, so this graphite, so basically you have these benzene ring kind of molecules, basically which are which arrange in a layered fashion. So it is formed by carbon. So carbon is the element that you have in your graphite pencil nib, right? So it is very soft. So that is why we are able to use it to write on a piece of paper, right? When you write it, you are basically rubbing on a piece of paper. Since it is very soft, basically to leave a trail. That is how we write it. So it is a very soft material. But if you look at diamond, diamond is also formed by carbon, isn't it? Both are carbon. Element is exactly same, but the properties are very different, isn't it? Graphite is very, very soft because its structure is very different from the diamond. Diamond has a tetragonal arrangement and atoms are connected in completely a different way. Although you have exactly the same element, both have exactly the same element. That means, what does this tell? The same element can give you different crystal structures. That means when you have a different crystal structure, the properties also will be very different, isn't it? So here, diamond, copper, both have carbon, structures are different, properties are completely different. So that means, so you can engineer them, right? If you know how to connect these atoms, then you should be able to engineer, right? Crystals, you should be able to engineer crystals. Then if you can engineer crystals, you will be called a crystal engineer. And that is what we do in our research lab, okay? So here, so you call these are allotropes, right? If you have molecules, for example, so then if the crystal structure is different, you call them as polymorphs. Okay, what is polymorph? For example, you have, say this is a molecule. So these boxes, each box is a molecule. Then you crystallize them. Then you get crystals. Then I get two types of crystals. One is having this kind of arrangement. Okay, another has completely a different arrangement. Arrangement is different. The molecule is same, exactly same. I use different conditions to grow them. Then I get completely different crystal structure. So what do you expect? If the crystal structure is different, you expect the properties also to be very different, right? As I showed in the case of graphite and diamond, right? Graphite and diamond are the allotropes of carbon. They have different properties. So here, if you have a molecule, if the structure is different in their crystals, then they can have completely different properties. So I'll take you an example which you use almost, you see every day, right? All of you know what it is? What is this? So this is a chocolate, right? So what is the molecule here? So this is the molecule that you have in this, and this is a major component. So this is what you have, and this is called cocoa butter. Okay. So your chocolate actually, if you look at different chocolates behave in a different way. Some chocolates you must keep in the fridge, right? There are some chocolates which you don't have to keep in the fridge, but as long as you keep it inside a room, not keeping on a hot plate or in the sun, so they are normally fine. Why? Although these are all chocolates made up of the same material and they have different properties. Do you know the reason? The reason is they also have polymorphs. The same compound can form different structures. The way these molecules can arrange would be different in these different forms. So it has 6 polymorphs. Okay. The same compound, depending on how you cool it down, you melt it, for example, you cool it down, depending on how you cool it down, you can have different structure. The way they arrange, solidify could be completely different. So that gives you different polymorphs. So all of you see chocolate something like this, right? So when you take a chocolate, and if it is from a fresh box, or if you take it from a good shop, always you will see them something like that, right? But sometimes when you store your chocolates and then you forget to eat them, sometimes they become like that, right? What is the reason? What is happening here? They go bad. Is it fungus or is it bacteria? No, this is actually simply a polymorphic transformation. So for example, most of the time you have chocolates in this particular form, but when you keep them in some other place, store them for a long time, they convert into another polymorph. So this polymorph is very shiny, smooth texture, good. And when you eat, it actually melts very smoothly in your mouth. But when you go to the other one, when it transforms to this form, if you see, it is also doesn't taste exactly same. It is hard and melts slowly in the mouth and shows some blooming like this. So this is a different polymorph. Basically, you are converting it into a different polymorph, and the melting points are different. If you melt them, it will be different. Whenever you find a chocolate next time like this, what you do is you just heat it a little bit. Okay, you just put it on a flame and then just move it a little bit, and you will see that it will turn into this kind of a texture. That means you are able to change the polymorph. Okay, you're converting it into a different polymorph. You're changing the crystal structure inside into a completely different arrangement. Okay, that is what you will be doing. Okay, understood what is the importance of structure and what is the importance of controlling the structure. If you can control the structure, then you are called a crystal engineer. Okay, that is what I do in my lab. So what is crystal engineering? How did it start? So engineering, all of you know, right? So engineering nowadays is very famous, and many of you must be planning to become engineers, right? So, but if you want to become a crystal engineer, and then these crystals are not like cars, right? Cars are very big, and you need electrical engineering, mechanical engineering, and many kinds of engineering if you want to become a engineer who designs the cars. But if you have to design the crystals, then your tools are not same, right? You need to go to the molecular level tools. You have to become a synthetic chemist to modify these molecules. If you modify them and then design them properly, then when they crystallize, they give you the right packing, and then you will be able to modify the properties. So that is what we do in our lab. What we do is we design soft crystals. So then we are able to, after you make the crystals, so they can bend, we can twist, you can do whatever you want to do with these crystals. That is what we do in our research lab, right? So he is the man from IISc Bangalore who proposed that we will be able to design the crystals if we understand how these molecules come together. Okay, so he said that if you can design these molecules, then you will be able to control the properties of crystals. And he's Professor Gautam Deshraju, with whom I did PhD. He is also called father of crystal engineering. And we have very few people who lead the international community, and he is one of them who leads the international community in this area. He is a very popular person. I was fortunate to work with him. For example, I'll give you a simple puzzle. Okay, so this puzzle, all of we do together. Suppose I have a benzene ring, and then I put a sticky group here. Okay, say this is a carboxylic acid group, and then this group, whenever another molecule comes, this group will stick with the other group and forms like this. So then if you have so many of molecules, what kind of arrangement we are going to get? So we will get something like this, right? They will stick, and then you will get a linear chain, right? But if you put these here, you make a molecule in a different way, then you are actually going to get like that. You can determine how they are going to come together and then form the solid, form this regular arrangement in the crystal. So this is how you can engineer the molecule. That will allow you to engineer the structures. Then you will engineer the properties. Properties also will be different. That is how we do it in the. So then when we were doing this using crystal engineering, and then people always thought that, crystals means they will be very brittle. If you just poke them, they will always break. For example, you take your pen or pencil and break them. They don't bend like that, right? And you take sugar cube or you take ice cube, you try to bend them, so they don't bend. So most crystals are like that. Then we showed that in 2012, actually the crystals were studied for thousands of years. But people did not know that you can bend crystals like this, and this we did from here, IISc Kolkata, and we published in 2012. This is a small crystal. This is a crystal of caffeine. So what you have in the coffee, we took that ingredient and then we complex with some other molecule and made this crystal. And then we found that you can actually bend it. So this is very, very unique, and nobody knew that you can bend them like that. Okay. So then now there are many people working on it, and after we started, a lot of people have, again, from different countries jumped into the field, and then they came up with many, many materials. This is the fluorescent one. You can shine the light, it will glow, right? You can twist, and crystals can also jump, you can bend, and many things can be done. So these are all now discovered. And then when we were working with our crystals, so we also found a crystal which actually, you break it, you make a crack, for example, and then automatically it will go and then heal itself. Okay, I'm going to show some videos. Suppose if you take your pencil and then you break it, So it will not come back. You take any material around you, you take a stone or you take a stick, anything you take around you, glass, whatever, right? Never it comes back and then heals completely, right? Never repairs itself. So this is very unique. And then, for example, if you break your arm or bone, so you, after some time, if you put everything together, after some time it heals on its own, right? It heals. So body can, or nature can self-heal. The biological materials can self-heal, but in natural materials, it is known, but in the synthetic materials, it is very, very rare. So we discovered a material, crystal basically, which heals itself. For example, you take here, as you can see here, you break it, then it heals completely. You break it again, it heals completely. So that we discovered, and then we published in a publication called Science, and it is very difficult to publish in Science, and it is the topmost journal in the international publications. Whatever you do in your lab, once you finalize your story, you can actually put it up on a research publication. So these are called publications. So you publish it, and then everybody else in the world, actually scientists and everybody, can read them, and then they can learn, and then they can try to develop. That is how this research basically goes on. And then when we published it, and then from Telegraph, somebody called me, and so somebody called me from Telegraph, and they said that we want to cover your story. And then I discussed with him and gave some pictures. And then next morning I see that, I was thinking that they will put it in somewhere and corner. I have to really search for it. But then I started getting calls in the morning, early morning, around 8 o'clock from all friends from Kolkata and different parts, saying that your work is on the newspaper. Then I opened the newspaper, and it was actually surprisingly on the front page. Normally whenever you open this, you will see either Prime Minister or, Chief Minister of West Bengal or somebody else. In this particular location, I was totally surprised to see this scientific work, kept on this, important place. So it was a big surprise for me. That's why I thought I'll show it to you. So what happens here basically? What is self-healing, right? So self-healing is very difficult in crystals because these are very rigid. You take any rigid material, it is very difficult to achieve this self-healing. So my student Surajit, who is now working in USA, America, with a Nobel laureate. So he was the one when he was doing PhD with me 2-3 years ago. So he found these crystals. So as you can see, these are all crystals, right? So these are all crystals which he made of this molecule. You crystallize it, then you get these crystals. Then he found that when you poke it with a metal needle, this is a pin basically. This video is taken at a microscope, and this is less than a, much smaller than a centimeter. Okay, this crystal, you poke it from one side with a pin, and as you can see here, it breaks, it cracks, but automatically it heals on its own. And no other material actually works like this. Are very, very few materials which can basically heal on their own. So this is called self-repairing nature, is called self-healing nature. So as you can see here, this is a slow motion video, and you can see here the crystal breaks, you see a big crack, then there is nothing. You don't see any crack after it heals. So it's so clean. So that is why it was very surprising. And then we, being a scientist, so we will try to see why it is happening like that, and we try to understand what is the reason for this. Why other materials don't do it, why only this does, and what is the uniqueness about these crystals. So we try to always find out the reasons, and then we discovered many interesting things here. And so I'm not going into the details, but you can see this. So then it holds why it is coming back on its own. So then we realize that there is an attractive force between these two pieces. As you can see, it would just jump, right? So see, there's a lot of force here. They're trying to come back on their own. It's a slow motion, okay? If you look at it under without microscope, high-speed microscope, you wouldn't see anything. Simply, you will just flash. You see that, everything again repaired itself. So as you can see here, we thought of, okay, let's see if there is an attraction. So then we broke crystals, then separated them a little bit, and then pushed one side a little bit. This is a slow motion. That is why you don't see it. And when it jumps, you see that, it is very fast, right? You can't see anything, even in the slow motion. So there is attraction. That attraction basically leads to this self-healing in these materials. So then we discovered, and there are other scientists who are also working on these crystals. So this is a crystal, you shine the light, so then it does like that, like a robot. You can even make it walk on the track, right? So you shine the light, then it does like this, and you put it on a track, it will walk. right? There are many things that we can do. Like, he's Professor Chandrasekhar from University of Hyderabad. So where, Venugopal sir is located. So next to his building, so Professor Chandrasekhar is actually taking some of these crystals, bendable crystals, and he's making the, these crystal wires, which can transmit the light, okay? Then you can, instead of using the electronics, you can use the photonics. You can use the light to make electronic devices or optical devices. So these are called photonic devices, and this is the next generation work. So Chandrasekhar is trying to do that. So then there are many other applications. For example, you can use these materials which we made in the soft robotics. This is also very interesting field. I think when you go into research, this would be one of the fields, to look at. So people are trying to, in some IITs, some scientists are already working on some of these. So you make some soft materials which can, under electricity or, some other stimuli, can, move, right? Then you can use them in the robotics. So this is what we do in our lab. And I tried to tell you something about the crystals, right? So now I ask you a question. How big can we grow the crystals? How big can they be? Okay. So if you look at here.
Hi, this is Randy Clark.
Okay, I hope you can hear the voice.
Incredible caves in the entire world.
Yes,
This cave.
Okay, see, these are the crystals,
like
okay?
one of the caves that we've all seen in the movie.
This is real, it's not a movie.
The movie Superman, in several of the movies, you'll see scenes in this crystal cave where Superman has this unbelievable information that's inside the crystals. Well, there actually is.
This is in Mexico.
Very much like the movies. It's in Mexico. It's in on the plateau near Chihuahua.
And
Mexico.
then you go into the
It's
cave,
about 1,000
then you
feet
see this.
underground. So you literally have to travel 1,000 feet underground just to find this cavern. But when you get down there, you will find the most incredible pieces of crystal that you've ever seen in your entire life. I mean, we're talking gigantic size pillars of crystal. And this is selenite crystal. Incredible. I mean, the views that you get inside this cavern are just absolutely spectacular. You'll see some of these crystal pillars that are so huge that it's just absolutely mind-boggling when you think of the weight, because some of these are as much as 55 tons. And to think that these all started from literally a crystal that was the size of a grain of salt and grew for 500,000 years in this cavern. Now, this main cavern here is just incredible. I mean, some of these are over 3 stories tall. I mean, this is just incredible to imagine what it would be like inside this cavern to take a look at these crystals. And just unbelievable. They're all over the place, and they go in virtually every direction of the cave. Some are growing, sideways. Some are growing up into the ceiling. Some are growing from the ceiling down into the ground. Now, this is one of the offshoots here. This is a little cave that's inside the main cavern, nearby the main cavern where those crystals are. This is called the Cave of Swords. And it literally is, it looks like thousands of swords coming out of the walls in this little cave. So incredible sight there. But these crystals are absolutely, incredible in terms of the size, because there's no crystals on Earth that even compare to the size of the crystals that are inside this cavern. I mean, you can clearly see this looks like ice cubes, but these are real crystal and just incredible. The quality of the crystal in some of the areas here is just off the charts, and the size is just.
Okay, I think I will stop here. And so if you want to join IISER Kolkata, for example, there are many other IISERs, right? Not only IISER Kolkata, but there are one in Tirupati, one in Pune and Bhopal and Trivandrum and Mohali and many places. So how do you, if you are interested in basic sciences, that means chemistry, biology, physics, maths, earth sciences. So if you want to join and if you want to go into the research side, so how do you enter into this system? So you look at this website, okay? And as you can see here, so you can search for IISER admissions, okay? You can search in Google IISER admissions or giant entrance test, or then you will go to this website, and then here you will see all the information. You can apply and many things you can do here. So what do we have here? If you come to ICER just after +2, many of you are, I think, in +2 or lower. So you can come to ICERs for the BS MS dual degree program. So this is a 5 years program where you start with BS and then you continuously go into MSc and finish MSc. So here, once you finish your first 2 years, you can actually go to the majors. Okay, you can go to any of the majors, and then there you can start working in the research labs. And finally, your 5th year is completely for the research. So you will be totally working in a research lab with the state of the art facilities and people who are working at the international level in the labs. In most of these labs are international level labs, so you'll be able to work in that. So this is a 5th year BSMS program. Then if there is anybody who who has already finished BSc, so they can also start with masters here. We have masters MSc 2 years, or we also have masters with PhD, and we also have PhD program. For PhD program, you have to finish masters. So we have all these options here at ICER Kolkata. So if you have to come for 5th year BSMS dual degree, for example, how do you come here? So there is something called aptitude test. If you go to this website, there is normally every year there is a call. So this will be advertised sometime in April 25th in the newspapers. Okay, generally in the April, not this is for the last year, but generally this website will give you all the information. And then you write an entrance exam. Okay, this is all ICERs together have an entrance exam, and you write it. You will be, if you qualify there, and then you will be able to basically enter to these ICERs through merit system. Then you can also basically write the IITG. For example, if you're writing IITG, there also, through that also you can, if you're above certain cutoffs, then you can also opt for IISR. So this is how you can basically get into ICER. So this is my group some time ago. And so this was in Hyderabad in some conference. So all these students basically work with me some years ago. Now we have other batch of students, and behind you see something here. So what is that? So that is basically a big, structure made by this person. So he's a crystallographer. So he made this using these balls and sticks, and then made it so big that anybody can understand what it is. So this is a crystal of internal structure of sodium chloride salt. So that is what you see here. So part of it actually was brought to Hyderabad for a conference, and then there we had an opportunity to display it to students, and many people visited that time. I think some students also came from KVs and many other places. That was in 2017. So this was a committee which basically organized that conference, and I was one of the organizers at that time. And here you see me, and here Professor Gautam Desiraju, who is father of crystal engineering, and you will see a lot of scientists from all over the different countries all over the world. So with this, I thank you all, and then I'll be happy to take questions.
So thank you for the wonderful presentation. And we are so amazed to see that the crystals could be so interesting. So yeah, thank you for this wonderful session. So before we proceed further, this entire journey, you would have faced many challenges. So can you just let us know about few of the challenges that you have faced during your research and your academic career?
Yeah, see, when you work as a researcher, normally in the lab, you go and, a lot of excitement, you go to the research lab and then you start working on it. And then initially you don't understand, everything and all. So you will face some kind of a difficulty where you're not moving at all. You keep working in the lab, you work very hard, but you don't get any results. So you get frustrated. So this is normal. But what happens in research is, although your experiments fail, still you are learning a lot. The process which you are going through is a big experience. So we should never think that, that is a waste. So in my PhD also, I did not get good results for almost like 2.5, 3 years. And that is when I was kind of a little bit got distracted, and then, then into other issues, like, there was a mess problem in the canteen and all. Then when you are not very happy with the lab, then you get into other things and all. But I was very sure, focused, and I was determined that, I had no other way. If you fail, then, so I had to go to the field, and then I had to help my father in the field. So I had no other way. I had to succeed. So I was working hard. Then I used that time to read a lot. And that gave me a lot of ideas. Then I started new projects. So those clicked. And those actually clicked because I was very keen in observing things. Okay, when you're doing something and then you normally target something, but around it, there might be many other interesting things. So these crystals, mechanically bendable crystals, for example. So this was not known in the field at all. Nobody did any work on that. So then I found some crystals with kind of, a lot of lines actually. And the day one, they were very clean and neat and very nice and shiny. I really loved the crystals. And then I went to the lab, and I used to just, take them in a vial and then show it to all the friends, whoever comes, see how beautiful these are. Then after some time, I realized that, they developed some small cracks. Then I was wondering, what are these cracks? Then I shook them a little bit. Then they become bigger and bigger. Then I took some out and then tried to play with them. And then I could see that they nicely slip like a pack of cards. Then I was wondering, so why these crystals are basically sliding like this? Most of the crystals simply break. And then I looked at the crystal structure. Then we found that these basically crystal structure has layers, molecular layers. So then these crystals also slide along those layers. So if you see, if you push, so exactly the angle at which they slide is exactly the molecular layer. So this allowed us to propose that. So these layers are sliding, and this was not actually, people knew that crystals deform, but why? What is the correlation to the structure? So these people did not explain. So then I started, checking every crystal, whether they also do it. Then we found that crystals can also bend. And this was something again new. Then we were wondering, so why is this bending? Then we started again digging it. It's like, CID investigation. Like, for example, there is a police case. The police would go and investigate, right, to find the answer. So we also do exactly the same thing as a scientist. So then we were basically curious to find out. Then we started basically manipulating mechanically all the crystals that were in lab, and we grew a lot of crystals, hundreds of crystals. Then we kept on finding many examples falling either into these shearing type ones or bending ones. Then we proposed a model. Then we showed why they bend. So then suddenly all this started in my 4th year. PhD is normally for 5.5 years. So many interesting things I got in 4th year. Until 3rd year, I was totally kind of bored. So it was a big challenge to stay focused and, keep motivated and keep improving your knowledge. So this was, I think, one of the biggest learning experiences for me. And our sir also was, very, he gave a lot of freedom for us. He never basically kind of accused or, kind of tried to pressurize us, as long as he knew that we were putting a lot of effort. So if you put a lot of effort, if you fail, people will excuse you. But if you don't work hard, and then you lose focus if you don't succeed, and then you will go totally in a wrong direction. So it is very important to stay focused, put good efforts, even if you fail, and everybody around you will appreciate, even if you don't show the results. So then at some point you get something, then you have the attitude, you have the knowledge, by that time you have gathered enough knowledge to really make use of that, observation into a discovery, and then you basically publish it. So that is how it works. So this was one of the examples. And then when I joined at IISER Kolkata, suddenly, it is a big transition from a student to a faculty. And this was again a lot of difficulty. And that time I just came in here, I had to start teaching. Teaching was also totally new. And then I had to establish my own research lab. And that was also totally new. I had to even fix the furniture, where the table will be there, where the window, and then, everything you have to do from scratch. I had no idea. Like, I did not even know how to measure the area in square feet. Then we had to learn so many things, and I had to read a lot of books to teach the students. And I also had to learn how to manage the research group. And it was everything, almost at the same time. And that time also I got married after I joined. So it was also totally a new life, and then a lot of responsibilities. So the whole thing was like, like a pressure cooker at that time, so many things at a time, new things handling, is very difficult. And I went through a lot of difficulty at that time, but I knew that, it's fine. I can take time, I cannot finish everything, but I was focused. I continued working on each and everything. Whenever I had to rise to an occasion, I had to rise, and then slowly, then things moved on. And then now you can see that, we have some good results to show it to the world.
Yes, sir, we can definitely see that now. So, sir, this would be my last question, and after that, students will be asking their question. So, sir, what is your vision for the students in India towards STEM careers, especially for girls? You'd like to know that.
Yes, see, there are a lot of opportunities in the basic sciences. Suppose if you're interested in science, you have a lot of opportunities. If you're not interested, if you're interested in engineering, absolutely you should go there. But each one has advantages and disadvantages. Okay, so it is not that you cannot earn money. If you are in science, you can earn a lot of money. There are very rich people. You can earn much more than what you can earn in, for example, in other areas. But if you are successful, and there is a lot of potential for technology transfer, from basic sciences. If you go to US, for example, a lot of professors are millionaires, so they have made their own companies, like, startups, using their students, and then together they have basically, they have now huge companies. So it is possible. There are a lot of opportunities, but if you're really motivated to do science, and you will enjoy it, and you can, it's like if it is your passion, you should come here. And it is always a very satisfying experience in basic sciences. You don't have any other external pressures. It is all your own internal pressure and your own peer pressure. And if you want to be successful, then you are under some kind of a pressure, definitely, because you yourself want to excel, and then you have to put a lot of effort. Sometimes things don't work. You're not happy with yourself sometimes. But there are a lot of opportunities, especially for girls. I can tell you, really, there are a lot of opportunities, because if you look at now, the ratio is very poor in basic sciences. It's not because scientists do not want male students to come, but it is basically because of the inflow that we have in each class. For example, if you look at our class here, now the students and younger batches are better and better. But in our time, hardly there were 2-3 girl students, and then they also do not continue for various reasons. So always there is a challenge. So now the system is reasonably better. I would not say that it is ideal, but reasonably better, and there are enough safeguards to support career steps for the girl students. And so there are many opportunities if you want to become a scientist. It's like a long journey, but once you get into a PhD, you start basically receiving some kind of a fellowship. So it's not like you are totally dependent on your family. So up to masters, you have to support yourself, or your family has to support. And but from after the masters, then you have basically some kind of a fellowship. It's around 30,000 to 40,000, depending on whether you're in first year, second year, or after second year, you get something like 40,000 at this point of time. For this, of course, you have to qualify an entrance exam. Then there are many of our students going to top labs in the world. Like there are many in the Cambridge, many in the IISc Bangalore. Some of them even join with us. They are everywhere. Good students, and many of them are very successful. And especially for girl students, there is a lot of encouragement, and so everybody wants more and more girl students to come into the basic sciences. And there are, especially in biology and many areas, already there are a good number of girls, female scientists in those areas. So yeah, I think if you have any specific questions that I can answer on this, but generally, definitely there are many opportunities in the basic sciences, particularly if you want to work in basic sciences. ICERs are right now having the right environment for students to basically get trained with the research as well as with the top teaching.
Thank you so much, sir. And the session was very encouraging and enlightening as well. So now I'd like to invite the students to ask their question. The first question is from Sulekha Taraftar, class 12th, JNV North 24 Paragnas.
Thank you, sir.
Matt, I think you have to.
Thank you, sir. We have watched and heard you with utmost sincerity. You are such a knowledgeable and intellectual personality. Can I ask a question from you?
Yes, sure.
Sir, crystal engineering is not a common term that we get to hear even today. So can you tell us how you thought of doing something in this field? Who guided you for this? Thank you, sir.
Yeah, you are not far away from me. So you are from 24 North Paragon, so which is very close to ISER Kolkata. So yes, it's a nice question. So basically, after my MSc, I was looking for some good professors. Actually, I didn't know that there is something like this. I was looking for some good research groups, and that is where one of my MSc teacher told me that there is a very good professor who works on crystallography and crystal engineering in University of Hyderabad. Then I had no clue. What she told me is that, you know, he's a very good scientist. He's a world famous scientist in that field, and you go and work on it, and it will be a nice field. Then I searched a little bit. In those days, internet was not very, you know, common. So I talked to friends, and then I met some seniors in the lab. Then they told me that this is some new area, which is basically a good area, and you know, a lot of things can be done. It has a lot of future because it is a new area, and there will be always more opportunities in new areas. So I kind of liked it, and not just because of this field initially, because of the professor mainly, because he was a very world famous professor. So I thought I will join in that field. So that's how I got to know about this field. And yes, you're right. Crystal engineering is not taught in MSc level, but nowadays people teach supramolecular chemistry, in which this is a small part. The supramolecular chemistry is broad, which goes from liquids to liquid crystals to solids and many other topics. But crystal engineering is a very specialized topic, and this has a lot of applications. For example, all these pharmaceutical tablets that we have, if you have to make these tablets, you need to understand how these crystals behave when you are basically handling them at different levels. For example, you have to mill them to get right particle size. If you have to compress something, you cannot have this much big particle, right? So you have to compress it and make a small powder, then you compress it. So when you try to make these small powders, so here the internal structure will have a lot of role. Sometimes the molecule may not be stable, it may react. In the crystal, suppose if two double bonds are very close, okay, then you shine the light, then they will react and you have a different molecule, your drug is gone. There's so many such issues. All these can be solved with crystal engineering. And this is a very new field. Even pharmaceutical industries are learning, actually. They want more and more people. And as soon as I finish PhD students who work in my lab, they finish the PhD, immediately there will be a call to me saying that, can he join my lab? There is always companies, many people are looking for good people in this area, and this has a lot of opportunities. Not only this, like electronics, organic electronics, organic semiconductors, any soft organic materials. In all these areas, crystal structure is important. That is why crystal engineering will have a lot of importance. Thank you.
Thank you, sir. It was quite a knowledgeable session.
Thank you very much for asking.
So, sir, second question is from Sai Divya. She is also from class 12, JNV Kurnool.
Okay.
Yes.
JNV Kurnool.
Yes.
Kurnool or Kurnool?
Kurnool, sir.
Andhra Pradesh.
Kurnool.
Yeah, your neighboring district.
Okay. Yeah, I studied is it in Rayalaseema, Kurnool?
Yeah, exactly.
Okay. I studied in Silver Jubilee College, B Camp in Kurnool.
Okay. Is she able to access the session?
No, sir, I don't think she's there.
What was the question? Can you read it out? Or...
Sai Divya, are you there? No, sir. So we'll take take another question.
Sure.
This is Punya Shri Nayak from JNV Mysore.
Mysore. Okay.
Yeah. Yeah, she is there.
Good evening, sir. Good evening, sir.
Yes, good evening. I can hear. Go ahead.
Sir,
Yes.
the
Yes.
session was so informative, and my question is STEM and the field of research still a man's world? Do you have any tips for us girls to come to the STEM pathways and succeed?
Okay. Yes, very nice question. So yes, so if you say it's a man's world right now because women has not been able to walk this path for various social and many other reasons, and but I'm sure there is a lot of scope, and if you have to succeed, I think see now if you look at girls are doing really well, and I think your generation is going to change this completely. I think I'm sure all of you are already on the path. I mean, I don't have any doubt about that. But specifically to answer for an individual and how to get through this and then reach to that path, stay focused, okay? And then, so in the life also, we have to plan things, at a family level, and always you need to discuss and then convince. Even for me, when I wanted to go to the research side, my mother was very upset. She was hoping, since I did a Bachelor of Education, so then she was thinking that I will write for exam entrance and then I will qualify and then I will become a teacher, school teacher. But I was very much interested in teaching, but I was equally interested in higher education and research. So I was more inclined to doing the research, but she was very upset. But I had to convince her that, there are other things as well. And then at the end, she was okay. So we have to, it is more like, you have to convince, it's more like a family thing most of the time. You have to convince and you have to also plan. And then you have to have a clear vision. If you have clear vision, then I'm sure definitely you can succeed. Women have several challenges compared to men, to reach it, because society normally thinks that, men should obviously go, and women sometimes, in some families, especially in social sectors, so it's a little different, right? So but these have to be worked out, okay? Individual level, each person has to figure out how to cross these obstacles. If you do that, sometimes this will look like big problems or big obstacles, but it is, if you just keep talking to the concerned people around, and then if you are motivated enough, and if you work hard, then I'm sure definitely women can do wonders. Yeah.
Thank you, sir.
Thank you so much, sir. So I got the question from S. Divya. So her question is, were you studious? I mean, did you study for long hours? And what was your study routine?
Okay, see, I think until my 7th class, I was not really that serious, but I was very regular to the school. And in the village, every day after we come back, we used to go and play cricket outside the village. So that is to be my routine. But close to the exams, definitely I studied hard. Like at least, in those days, I was not that good, but I was always at least in the top 5%, although I did not work very hard in those days. But then when I went to the 10th class, 9th and 10th, then my family was, kind of forced me to be more and more serious. And then that time really I studied very hard. From my 9th class, I always studied hard. Always there was a scope for play and other things. And but at least 3 to 4 hours I used to study after the school. 3 to 4 hours, and then during the exam I used to sit continuously till late little bit, and I used to get up in the morning, and then during the exams, yes, up to my 10th class. Then in the 12th class I really wanted to go for MSET in those days, to become doctor, or it was very much right, I was focused, and then I was reading chemistry and maths. I worked very hard in the +2. But still my college was not that great, so I had difficulty. Then after the exams are over, +2 exams are over, I had 3 months time, 2 months time, I think, to prepare for the MSET. That time I was continuously on the books actually. So morning to evening, only sleeping and a little bit of, other things, but mostly like 10 to 15 hours, I studied very hard. Then I see in when I went to the BSc, then I was in the hostel. In the hostel, then you don't have anybody else to tell you what you need to do, and then you have a lot of friends normally, and then normally friends get together and then play or chat, and most of the time goes in a very jolly mood, right? So that time it was very difficult, but I knew that if I don't study, if I fail, I have to go back to my village, and then I have to help my father in the field. So my father used to always say that. So then I figured out that if I don't study, it will be a big problem, because I knew that if I have to get CSIR, get my own fellowship to do the PhD, I have to get this CSIR fellowship. So then what I did is until 5, 6, I used to be with friends. After we come back from college, then up to dinner I used to be with friends and all, normally chat and all. Then they would go to sleep. Then I would then I would sit till 3 o'clock in the morning, sometime closer to the exams, particularly 2 o'clock, 3 o'clock, and then I will get up late. I always used to study much harder than other students. So I had to figure out, you have to find a way. You cannot also say to your close friends that you want to go and study. Sometimes they will make fun of you and all kinds of things sometimes, right? And so it was a problem, but I had to always find out a way to study well. But I was never a topper in the class, but always I was second, third, or fifth, something like that. And but I feel that if I had studied from my school days, even from the lower school, very hard and learned everything, I would have been a slightly better person than what I am now. For example, in my +2, I kind of scared of the mathematics. So now when I have to do some maths here, even simple maths, I feel a little bit difficulty. But some of my students who are with me, and they were very good students, and I see that they do things just like that. Even if you have to go outside your area, and those are very basics. These are not very high funda stuff, but simple basics. But in other field, like for example, I know biology reasonably well, because I was equally interested in biology up to my BSc. But maths was a difficulty for me, and I did not study that well because I had to, up to +2, I studied well, but up to 10th class, even what I studied in those days, amount of time I spent was extraordinary compared to all other students. That's why out of 60 students, only 2 to 3 could pass. But if you compare to the competition that you have now, if I'm like that, and then I would be nowhere actually, right? But I see that, your generation has, because I know that most of the students now in your generation study very hard, and you are basically try to be equally good in almost all the subjects. So if you have that, it will really help you when you go into a specialized field, because you understand many areas much better. So you need in-depth understanding in your area, but it is equally important to have large knowledge on wide area actually. So you need both breadth and width and breadth. Both are important if you have to really go to the top. If you want to succeed, it's fine. You can there are many ways to succeed. If you see that you need 4 to 5 good qualities, you have to work hard. Okay. And you should plan things and focus properly. And then you should also have self-motivation to, overcome many things. See, intelligence is it's a bonus, but it is not it's like a bonus. Okay. Almost everybody has, a good level of intelligence. But it's always a bonus, and you can do many extraordinary things if you are very intelligent naturally. But this will only add up if you have all these basic things. If you don't have this, if you are very intelligent, but you don't spend time, if you're not sincere, if you are not focused, today you do something very intensely, then tomorrow you take up something else completely different, then you will not reach anywhere. So the basic qualities are with everybody. So if you focus, if you are motivated enough, then I think everybody can, all of you can succeed actually. Okay, I hope it was useful.
Yes, sir. Thank you so much, sir, for the enlightening session. And now we'd like to end the session, and I'd like to invite Ms. Jesli for the vote of thanks. Welcome, Jesli.
Yeah, thank you, Sonal. So first of all, I should thank you, sir, Dr. Reddy, sir. The session was very enjoyable. It was so enlightening, really motivating. I was enjoying the session thoroughly from the start to this second. without blinking an eye. So I know the enthusiasm and the positivity which is running through the minds of all the students, especially all the girls out there. So I thank you so much, sir, really from the bottom of my heart. And especially the simple things and the most heart-touching things which you told are really motivating. For example, you told twice, I guess, that if I don't work hard, I have to go back to the field. So I don't think like anybody at your level, I have not heard. So it was so good of you, because even we have gone through that, but I have not heard many people say that. So it shows your humble nature and that simplicity. So it is really good, sir. And the same humbleness and the simplicity you showed in such a complex field like crystallography. The presentation was so simple, and it was reaching, I think it will reach anyone who don't even know chemistry also. So thank you once again, sir. So I wish you good luck in all your future endeavors. And I really envy all your students, sir. We should have research scholars or teachers like you. So God bless you, sir. Thank you so much for coming.
I have a small request.
Yeah,
Yes.
thank you. Yes.
I have a small request for you, Malla Reddy. Next time when you come to Hyderabad, please visit one or two of the ANVs.
Sure, sir. Definitely. It will be a pleasure for me. I also miss the students directly, seeing them directly and then interacting would be much more fun than, this one-sided interaction. But I am sure.
It's our privilege to have you on board with Vigyan Jyoti program. Whenever your schedule permits, kindly visit a few Navodaya Vidyalayas and talk to the girl students.
Definitely, yeah. Definitely, yeah, it will be my pleasure. Definitely, we will do it.
Thank you so much. Thank you.
Yeah, thank you all. Thank you all for a wonderful session, and I really enjoyed it. And I'm sure all of you will be very successful, and we will meet somewhere.
Thank you.
Thank you, sir.
Thank
you,
you,
everyone.
Thank you, everyone.
Thank you, everyone.
Yeah, I take this opportunity to thank Gopal Krishna sir, Modi sir, and all the support given to us, and Minu ma'am and Sanjida ma'am also. And now I should thank all dear teachers who gave the opportunity, in spite of all those busy schedules, they allowed the children to come, sit, and enjoy this good session. So thank you, teachers. Thank you, my dear children, students, and thank you, my team members, especially Sonal. Thank you.
Thank you all. Thank you very much.
Thank you, everyone.
Thank you very much.